video, right? The one of the biggest things you used was the fact that perimeters have the same scale factor, right? Have the same scale factor as when you're working with dilations or similarity. Okay, so if you knew the dilation was 2, then you can just go ahead and do the same exact thing, right? You can just multiply the perimeter. But now I'm going to go ahead and do the proof of why this actually works. And I'm going to do it with one shape only, but just understand that it works pretty much the same way, okay? So the shape that I'm going to work with is a rectangle. Okay, so I'm going to go ahead and call them two different rectangles, and I'm going to say that they are similar. Okay, they're similar with the scale factor. Let's just go ahead, and all I'm going to do is call it basically SF for scale factor. Okay, this is a number. It could be 1.3, it could be 0.5, whatever. It's just a scale factor. So for the first rectangle, I'm going to go ahead and call this one length, width, length. Okay, and then for I'll call it L1, W1, and then there you go. And then let's imagine we, dilated this and we multiplied by the scale factor every single side. And now it's going to become L2, L2, W2, W2. But now let's go ahead and be even more specific. I actually know how to relate L2 back to L1. It's going to be, you multiplying L1 times the scale factor that I give you. For instance, if it was times 2, then we would multiply times 2 everything. If it'd be times 0.3, then it'd be times 0.3 everything. Since this is a proof, I'm going to just keep it as SF, okay? So what that means is I can change every single one of them to the initial sides, times SF. So this one is equal to L1 times SF. And same thing, this is going to be equal to W1 times SF. The only reason why this looks really confusing and there's like a lot of letters here is because we're working with variables as opposed to numbers. But if you really think about it, it's basically just using numbers and replacing them with letters. Okay, so now how does the proof actually work here? So I'm going to go ahead and figure out, since we're calling this one 1 and I'm calling this one 2, the perimeter of rectangle 1 is just going to be equal to L1 plus W1 plus L1 plus W1, right? Because all I did was add all sides. So technically this gave me 2L1 plus 2 W1s. And that makes sense because, you're working with the same sides because I'm working with rectangles here. All right, and so this here is the perimeter of our first rectangle. Now, behaving in pretty much the exact same way, I can go ahead and I can figure out what the perimeter of the second rectangle is. So I'm going to go ahead and start it off as well. So L2 plus W2 plus L2 plus W2. Now the only difference though is I can go ahead and substitute all of these new sort of definitions for L2, W2. Okay. So then L2 technically is going to be, well, actually first I'm going to do this. I'm going to change them to 2L2 plus 2W2. Okay, it'll just save me some space, some time. And so what this means is that it'll become 2. Now instead of writing L2, I'm going to go ahead and write L1 plus S. Sorry, not plus. Sorry, that's super important. It's actually going to be times. Okay, L1 times SF. And then plus 2, instead of writing W2, I'm going to write this one, W1 times SF. Okay. And so some of you can probably already tell that we're getting really, really close to showing it. Okay. So let me go ahead and we're almost there. Now, if you notice on this side, I'm just going to drop the parentheses. I'm just going to write 2L1 times SF. Sorry, that looks really messy. Okay. So let me do it like this. All right, equals 2. So I was going to drop it. So times L1 times SF plus 2 times W1 times SF. Now, if you notice, you have only 2 terms here, right? Just because they're being separated by a plus sign. I know it looks messy, but just think about it. This first term here is just 2 times a number times a number, right? And then the second term is 2 times a number times another number. Now, notice how both of them has SF in there. Okay, so both of them has an SF in there. What that means is I can actually factor out that SF. Okay, and this is now where you get into stuff from before. So factoring out the SF, and I can go ahead, sort of think of it as like, reverse distribution. It's when you took the GCF when we are working with like quadratic formula. So 2 times L1 plus 2 times W1. The reason why this works is because if you really, really think about it, if I were to distribute the SF to both of those terms, I would just get back to first initial problem. And so then what I end up having here is this P2 here. So look at this here and compare it to this one here. It's technically the same, 2L1 plus 2W1, 2L1 plus 2W1. The only difference is that you have an SF in the front. And if you remember, the SF is the scale factor. So what this really is just showing, it's that the perimeter of the second shape is the exact same answer, 2L1 plus 2W1, but just times that SF. So, and technically, that's what you're doing for every single dilation or every single similarity. Okay, so that right there is the proof.